In this example, which is the 20 series Sunstrand hydrostat system, we're going to look at a couple of common problems that can happen in terms of troubleshooting. Things like a loss of drive in one direction, things like overheating, loss of drive in both directions, low power, things like that. So on a system like this, if you looked at the other video that we put together, we'll have talked about how all the components work and what normal operating pressures and flows are while things are happening. When things go wrong, then you should see some differences in your pressures and in your flows from normal. So to start off with, let's go with the loss of drive in one direction. Okay, when you have a loss of drive in one direction, in most hydrostats, we can usually attribute that to one of three things. It could be a charge check. It could be high pressure relief. Okay. Or it could be a stuck loop flushing spool. So if the loop flushing spool or shuttle valve is stuck one way, if the high pressure relief, if one of those is opening at too low of a pressure, or stuck open completely, or a charge check, if a charge check is stuck open. So those are the three scenarios where we would lose drive in one direction, the three most common scenarios anyways. With a lot of modern hydrostats, the charge check and the high pressure relief are part of a multifunction valve, and that cartridge is usually located on the pump. If you suspect that one of those two things is the problem, the simplest thing to do is just switch the multifunction valves around and see if the problem goes to the other direction. Okay, but we want to talk about what happens with our pressures when we've got an issue with, let's start off with a charge check. Okay. So if we had a, let's say a reverse charge check that was stuck open, that means that when we try to go in reverse on the machine, nothing's going to happen. But when I try to travel forward on the machine, it's going to work just fine, because when I'm going forward, the reverse charge check is supposed to be open anyways. Okay. When I try to travel in reverse, we have a bit of a problem here, and that problem is that we've got a 40, and in our example here, we said 40 gallons a minute out of the hydrostat pump. Realistic or not, those are just the numbers we assign to it. So if I've got a 40 gallon a minute pump that's pumping oil out, it's got two places to go now. All right. And part of the oil coming out of the pump when I'm trying to go in reverse is going to go back through that open reverse charge check and back feed into the charge circuit. That puts a significant amount of flow into the charge circuit, and that's going to make the pressure in the charge circuit go up when I go in reverse. When I go from neutral into either forward or reverse, the charge pressure is never supposed to go up. It's always supposed to drop a little bit. The reason it drops, like we talked about earlier, is the loop flushing spool or shuttle valve shifts over, and now we expose the purge relief, which is a lower pressure relief in the charge circuit, to the charge circuit. So you got a loss of drive in one direction. And that loss of drive in one direction is causing the charge pressure to go up when you're testing the system in that direction. That means you got an open charge check. Loss of drive in one direction where you have a shuttle valve that's stuck one way. All right, now let's just imagine for a second that the shuttle valve was stuck up. If my shuttle valve is stuck in the upward position, that means it's stuck in the direction it's supposed to be for when we're traveling in reverse, correct? So when that thing is stuck up, that means that in reverse, it's going to work normally. In forward, it's not going to work at all. Now, why is that? Well, when we're in forward, we're trying to send oil from the hydrostat pump through the hydrostat motor. But the oil's actually got two paths to go now. When I shift the loop flushing spool up, I'm opening up a flow path like so. And that means the oil that's coming from the hydrostat pump is going to want to go down through here, across here, through my purge relief, and effectively to tank through the case drain system. So what happens? Well, we got a big pump that's actively pumping itself empty through a stuck open purge relief, or not a stuck open purge relief, but a stuck open loop flushing spool, and then through the purge relief. So if I've got a hydraulic pump that can pump 40 gallons a minute, and it's trying to dump that oil out as fast as it can through the easiest way it can go, and I'm also trying to make up for any leakage losses with the charge circuit, I got a 10 gallon a minute charge pump trying to feed a 40 gallon a minute pump that's busy pumping itself empty. What do you think is going to happen to my charge pressure? My charge pressure is going to go pretty much right down to zero. Okay. If you've got a loop flushing spool that's stuck one way, when you drive in the direction that everything works normally in, everything's going to work normally. And your charge pressure, your drive pressures, your stall pressures, those are all going to look just fine. All right. You switch it back to neutral, you're going to notice something. You're going to notice that your charge pressure doesn't pop back up to the neutral charge relief value. It stays down at the purge relief valve value. The other thing that you'll notice is if you are monitoring flow on the motor case, which you may or may not be, depending if you have a flow meter in there, you'll notice that the flow never stops. The flow should stop in the motor case if that loop flushing spool moves back to the center position when you're in neutral. But then when you go into the forward direction, you're not going to go anywhere. You're not going to have any charge pressure. All right, your drive pressure, there's going to be pretty much no drive pressure there either because we're trying to pump with a pump that doesn't have any oil supplied to it. So we're going to see a complete drop in the pressures. If you got a high pressure relief valve stuck open, this is one where it depends on the way the high pressure reliefs are arranged, what's going to happen with your charge pressure. Okay. One thing that'll happen for sure is if your high pressure reliefs are stuck open or opening at too low of a pressure, your drive pressure is going to be very low or not there at all. Your charge pressure might be normal or it might go way down as well. Okay. Now, in this scenario, because of the way that this 20 series is laid out, if I got a high pressure relief that's stuck open and it's dumping oil to tank by following that path right there because of a stuck open high pressure relief, that means that once again, my hydrostat pump is busy pumping itself empty to tank faster than the charge pump can fill it back up on the suction side. My charge pressure is going to go down and my drive pressure is going to be non-existent. All right. Now, if you have the other style, some of the other hydrostat systems out there, what they'll do is your high pressure reliefs, they act more like a crossover relief, okay? And they do this. Now, if this was the case, that would mean that if the high pressure relief was stuck open, it would just be dumping back into the other side of the hydrostat, so it's not actively pumping itself empty. And if it's not actively pumping itself empty, that means it's not placing additional load on the charge pump, or additional flow demand, I should say. So if there's no additional flow demand on the charge pump, now the charge pressure is not going to fall on its face, but your drive pressure is not going to be there. Okay. There's other systems as well that dump from the high pressure relief into the charge circuit between the charge checks. And again, in this scenario, it doesn't really matter because instead of going straight over to the other side, it goes through the charge check into the other side. It's the same thing. So once again, charge pressure is not affected, drive pressure is not there. If you suspect that you've got a problem with your high pressure relief or a charge check, on a lot of systems nowadays, the easiest thing to do is to swap the multifunction valve cartridges. Okay. So if you got low power or overheating, that's another really common problem that you have on hydrostats. And with low power and overheating, normally that's one of two things. Either things are worn out or things aren't adjusted properly. Okay. If things aren't adjusted properly, that could be a D-stroke or a relief problem. Okay, and when I say D-stroke, I'm just trying to be general here. But when I'm talking about D-stroke, I'm talking about things like a pressure override or a pressure cutoff. It's the mechanism that we use to D-stroke the hydrostat pump when the drive pressure gets to whatever our max limit is. Or high pressure relief. Set too low, you don't have power because we're not developing the same pressure that we should in the system. If the hydrostat pump or the hydrostat motor is worn, the same thing's going to happen. Okay. So how do I differentiate between those two? How do I know which is the problem? If I put a pressure gauge on the system and I do a stall test and I see that my pressures are low, I could go ahead and try to make some adjustments and see if that's the problem. But if I want to make sure that the reason the pressures are low is because of a misadjusted pressure cutoff valve or high pressure relief and not a worn out pump or motor, is there another test I should do first? And the answer is yes. What I should do is I should check and see if I have excessive case flow. Okay. Now, if I want to see if I got excessive case flow on my pump or my motor, there's a couple of ways to do that. Starting off with the hydrostat motor. If I have excessive case flow on the hydrostat motor, that really does indicate that I've got excessive internal leakage in the motor. Do a stall test. Set the brakes, lock a wheel somehow, and go ahead and stroke the hydrostat control lever. Take a look and see how much flow you have coming out of the case drain. If you want to see how much leakage you have on a hydrostat pump, what you'll want to do is, again, do a stall test, but take a look and see what the difference is between the output of or not the output of the case, the total flow going back to the cooler and the total combined flow coming back from the motor, combined flow being motor rotating group leakage and any purge flow present. Take a look at the difference between those two, and that's going to tell you what your your pump rotating group leakage is going to be. Another classic indicator that you've got worn out components, not necessarily misadjusted, is when your customer's coming to you complaining that they got low power and it's overheating, and then you ask them a question or two and they say that it's a little bit better when it's cold, but it's really bad when it's hot. To me, that says I got a problem with probably valve plate and rotating group leakage. We've got some excessive wear there, got too much oil exiting there. That equates to higher than normal case drain flow. One other thing that does happen sometimes is you lose drive in both directions. And if you lose drive in both directions, there's a couple of different reasons why that might happen. Maybe the control input is just gone. By that I mean maybe the wires fell off of the solenoids on the valve on the pump. Maybe the linkage is disconnected. But if the control input is okay, then the next most likely thing is that the oil supply to the displacement control valve that controls the servos for the swash plate is blocked. And if it's not that, then the spool, the actual spool, the displacement control valve itself, is probably stuck. All right. So all of this here is going over some common troubleshooting. There is one other thing that I do want to go over before we wrap it up, and that is what happens when you got a hydrostat drive that's creeping. And when I say creeping, I mean that you've got the controls in neutral, but it still wants to drive, okay? So maybe it's going forward, maybe it's going reverse, it still wants to drive. And if it's creeping in neutral, you can attribute that to one of three things, okay? So the first thing is linkage. If you have a problem with the linkage, maybe your linkage isn't adjusted correctly, so it's holding the control lever on the pump in a slightly applied position, maybe forward or reverse, it's going to want to creep in that direction. Disconnect the linkage and see if it stops creeping. If it's electronic control, maybe it's electric over hydraulic, disconnect the harness and see if it stops creeping. Or run a calibration and see if it stops creeping. But if that's not the cause, then the second thing that it could be is a hydraulic problem. When I say a hydraulic problem, what I mean there is the spool in the DCV is not actually going back to its proper neutral position. So it's always leaking a little bit of oil into the servo circuit on one side. So even though the control input, the linkage is in neutral, the valve itself isn't going back to neutral properly. So when we've got a linkage issue, the first thing we do there is we just disconnect. If disconnecting doesn't help, and we think it might be a hydraulic neutral issue, then what we'll do is we'll put a loop hose on. Okay, and what a loop hose does is it joins together both sides of the servo and hydraulically balances them so that if it was a leaking valve that was causing the swash plate to tip and make the machine creep, it'll balance out and it'll stop creeping. If it doesn't stop creeping, even though you got a loop hose on, then it's not a hydraulic neutral problem, and then you're left with the last possibility. Your mechanical neutral is not adjusted properly. And when I say mechanical neutral, what I mean is the swash plate centering springs, the servo centering springs, the mechanism it is that mechanically centers the swash plate is not adjusted right. And depending on the style of pump you have, the way that you adjust that back to a proper neutral is going to vary. But if you got your linkage off, you got your loop hose on and it's still creeping, you're going to have to center the swash plate. On some designs, it's quite easy. On others, it's a little bit more involved.